Assalamu alaikum. I am SN Rakib Hassan, ID 222411038 from team number 4, and I'll be presenting the paper titled Tweet NLP Cutting Edge Natural Language Processing for Social Media. My research assistant is Mohammad Humayun Kubir Mehdi sir, and ST is Mohammad Musa Genalo. So let's just dive into it. At first, let's discuss what is Tweet NLP. It is an NLP platform specialized in Twitter, offering transformer-based language models that have been trained and fine-tuned for specific NLP tasks on Twitter data. Despite the challenges posed by noisy, multilingual, and context-lacking data in social media, Tweet NLP offers an easy-to-use Python API and an online demo for anyone to test and perform real-time analysis on Twitter. It integrates base models that are easily run in standard computers or free cloud services and has already proved highly popular with thousands of downloads from the Hugging Face Model Hub every month. So why is it actually needed when there are so many models outside? So several general purpose NLP libraries have been available for years, but none is specialized in social media or Twitter. Low-level social media libraries are mostly limited to tokenization, POS stacking, and dependency parsing. The most recent Twitter-specific Python library is TweetBank NLP based on Stanza, which provides state-of-the-art models on tokenization and lemmatization, and competitive models on NER, POS stacking, and dependency parsing. So how exactly does this model work? TweetNLP specializes in Twitter-specific language models for downstream tasks such as sentiment analysis and offensive language identification. The library offers an easy-to-use Python API and an online demo for real-time analysis. The backbone of Twitter NLP is transformer-based language models. It relies on specialized language models that are pre-trained on Twitter-specific corpora. The language model used are relatively small in size based on Roberta-based XLM R-based architecture, making them efficient on standard hardware. The library includes three pre-trained language models: TweetEval, TimeLMS, and XLMT. It is based on Roberta-based architecture and was pre-trained on a corpus of 60 million tweets. TimeLMS is a more recent model, pre-trained on a corpus of 130 million tweets, with an improvements in pre-processing and regular updates. XLMT was trained on 198 million tweets, over 30 languages, and uses XLM R-based initial checkpoint. About its scopes, it has many scopes like sentiment analysis, which predicts the sentiment of a tweet as positive, neutral, or negative. Also, it has emotion recognition, associates a tweet with its most appropriate emotion. The reference dataset used is the SemEval 2018 task on effect in tweets. For emoji prediction, it predicts the final emoji on a given tweet. The dataset used is TweetEval adaptation from the SemEval 2018 task on emoji prediction. Irony detection is a binary classification task that aims to detect whether a tweet is ironic or not. Hate speech detection detects whether a tweet is hateful towards women or immigrants. Also, the offensive language identification identifies any form of offensive language in a tweet. Stance detection asserts whether the author of a tweet has a positive, neutral, or negative position towards a target topic. Topic classification assigns the topics related to a tweet's content formulated as a supervised multi-level classification problem. Last but not the least, named entity recognition finds entities and identifies their entity types in a given sentence. The underlying Twitter NER dataset is composed of over 10,000 tweets annotated with 7 entity types. Moving on to embeddings, which is the core part of the model, the authors of this paper have developed models that can understand human languages and have also created tools that can represent words and tweets as low-dimensional vectors. These embeddings can be used for a variety of tasks, such as finding similar words or tweets or retrieving specific tweets. They train two sets of word embeddings, one for English and one for multiple languages, and a set of tweet embeddings using a method called contrastive training. These tools can be used by researchers and developers for various language-related tasks. For word embeddings, it is based on fast text and trained on Twitter corpus. Two sets of embeddings, monolingual and English and multilingual. It is trained with 300 dimensions and interval sizes of 2 to 12. For tweet embeddings, it is trained on tweet reply pairs from Twitter API. It uses contrastive embeddings with info NC loss. For positive pairs pulled together and negative pairs are pushed apart. It is trained on 1.1 million tweet reply pairs and separate set of 10,000 pairs used for model selection. Moving on to the usage, the text describes the TweetNLP Python library that has been integrated into PyPy 4 and can be installed from pip. It also provides access to underlying Python code structured in instructional Google Colab notebooks. The tutorials provided in Tweet NLP website include the introduction to Tweet NLP, which provides an overview, getting data from Twitter, which teaches how to retrieve the data, custom fine-tuning, which instructs how to fine-tune any given language model, word embeddings, which show users how to train their own word embeddings on custom data. Also, language models over time explain how to use language models that have been trained in short periods of time. Finally, tweet embeddings, which provides examples on how to transform a tweet into a vector. The website also includes a web-based demo integrating all the models, which has 5 main functionalities like sentence classification, hashtag analysis, word prediction, tweet similarity, language identification. Furthermore, to evaluation, the datasets used are, except for tweet classification task, tweet eval datasets were used. For tweet NLP users, time LMS for English and XLMT for non-English languages and multilingual tasks. The performance of original tweetable baselines were compared with including frequency-based SVM classifier, fast text, bidirectional LSTM, Roberta base, BOB Twitter, and tweetable Roberta base model, along with BR tweet trained on 1 billion tweets from 2013 to 2019 is reported. Also, the fine-tuning is performed on the training sets of each corresponding dataset using their corresponding development sets for validation. For results, in multilingual sentiment analysis, the domain-specific XLMT language model achieves the best overall result in all languages. In case of word embeddings, the race embeddings outperform the standard pre-trained fasttext in 2 datasets. There are 9 sentiment analysis fields where the model outperformed in every sector but 2. To conclude, Tweet NLP is an all-round platform for NLP specialized in social media. It offers an online demo, a Python library, and a tutorial to make the most of the models regardless of the user's expertise. The models can be inspected by non-programmers, which helps identify harmful biases or errors and improve models in the future. The goal is to keep updating Tweet NLP with new models and tasks and support languages other than English in a wider variety of tasks. Thank you for your patience. That's all for the presentation.